For this problem, we are finding the derivative of p evaluated at x equals 1. So before you can actually find the derivative of p at 1, we are going to find the derivative of p of x. You'll notice that f times g is a product, which means we're going to use the product rule. So the product rule, you're going to do the first thing, which is f, times the derivative of the second thing, which gives you g prime, plus the second thing, which is g, times the derivative of the first. Then we are going to evaluate that at x equals 1. And we're going to use the table that we have there. So we have f of 1, we know that's 3. We have g prime of 1, we know that that's 9. We have g of 1, we know that that is also 3. And f prime of 1 is negative 1. So we end up getting 27 minus 3, which gives us 24. So for this one, you are going to get 1 point if you did that first step, and you get the second point for that if you get 24 in the end. This is a two-part problem. The next thing we're going to do is find the equation of the tangent line. Luckily, we already know that our tangent line, which has the equation y equals mx plus b, we already know what the m is because we just found that. M is going to be equal to 24. So to figure out what b is, we need a point. The x value of our point we know is 1. To find the y value, be careful, we're not using f of 1, we're using p of 1. In order to find that, we actually know, they tell us in the very beginning, p of x is going to be f times g, so p of 1 is going to be f of 1 times g of 1. We know that f of 1 is 3. We know that g of 1 is also 3. So we get that p of 1 is equal to 9. By the way, if you did that right here, that gives you another point for this problem. Last thing we're going to do is write the equation of the tangent line. I actually think it's a lot easier just to write it in point slope form. We get y minus 9 is equal to 24 x minus 1. If you write it as y equals mx plus b, totally fine. It's just a little bit longer. But this is completely sufficient for finding the equation of the tangent line. So that gives you the last point. So part 2, we have a quotient and we're finding the derivative of the quotient. If you are finding the derivative of the quotient, make sure that you use the quotient rule. So we're going to do q prime of x first and then we'll evaluate 2 after. So remember quotient rule, you're going to do the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Then you are going to evaluate that at x equals 2. So you should end up getting g of 2 times f prime of 2 minus f of 2 times g prime of 2 all over g of 2 squared. Then you can use the table to substitute in the values of g and f at 2. And if you work this whole thing out, you should get 3. So far in this problem, if you did the quotient rule, you get a point. If you got 3, you get your second point. So the next thing is the normal line. So the normal line, we don't talk about it too much in calculus, in AP calculus. However, it does occasionally come up on the AP test, so hopefully you remember it. So the normal line is almost the same thing as the tangent line, except it's going to be, instead of being the line that's tangent to it at that point, it's going to be the line that's perpendicular to the tangent line. So you still find the point the same way. The slope is a little bit different. So your slope, remember when we have a perpendicular line, you're going to do the negative reciprocal. So my slope is going to be -1 over the value that I just found, which gives you -1/3. So this is the slope of my normal line. By the way, if you do that, you get 1 point. Last thing I need to do is find the equation of that line. So I'm going to use that slope, and I'm going to use the point. So I have x equals 2. And in this case, I can find my second value here by doing q of 2, because we're finding the line normal to q. In order to do that, I get f of 2 over g of 2. F of 2 is 0. G of 2 actually doesn't matter because I have a 0 on the top, but it's 1. So my answer right there is going to be 0. So when you find your equation of the normal line, I'm going to use, by the way, I'm going to use point slope form again. I get y minus 0 is equal to -1/3 times x minus 2. You don't need to simplify that. This is perfectly sufficient. And if you get that, you get another point. So the next problem, I have c of x equals f of g of x. We're finding the value of c prime. This is a function of a function, or we also call it a composition of functions. In order to deal with the composition of functions, you are going to use the chain rule. So with the chain rule, remember, in order to find the derivative, you're going to do the derivative of whatever's on the outside, in this case the f, and keep the inside the same. Multiply that by the derivative of whatever's on the inside. So if I have x equals 1, I am going to get this right here. I get f prime of g of 1. G of 1 is 3. G prime of 1 is 9. So now I'm going to use f prime of 3. That's going to be 1. So I get 1 times 9, or 9 for my answer there. By the way, to get the points here so far, you would get 1 point for doing the chain rule. You get 1 point for getting that value. The last thing we're going to do is the tangent line. I'm going to use, you can use y. I think I've been writing out y equals mx plus b, but then using point slope. I'll actually write down the point slope form. So we need a point, we need a slope. We know our slope is 9. Our point we can find by figuring out what the value of c of 1 is. So c of 1 is going to be f of g of 1. I know that g of 1 is 3. I get f of 3, which I know is -2. So I'm going to use the point 1, -2. My final answer here is y minus -2 is equal to 9 times x minus 1. Actually, if you put all of this, you would get full credit. You don't need to even simplify your equations, or your negatives, but you can. And so I'm going to write the answer like this. One thing on these problems I do want to caution you about is if you write it in point slope form, occasionally they will ask you to find an equation, and they'll tell you to find an equation that says y equals f of x. If they actually specifically say to find an equation where it says y equals f of x, you have to solve that for y. Just a little hint. On this type of problem, you don't usually have to do that, but that's just kind of a side note. So in order to get full credit on this problem, you would need to do get -2, and then you would get this full equation in the end. So I'm hoping that you thought that the previous 3 problems were somewhat straightforward. Maybe if you forgot what the normal line is, or if you were absent. I think we spent maybe 1 day of class doing that type of thing, maybe like a half a day of class, so you might not remember it. But hopefully you kind of are okay with those. D is a little bit less straightforward. Luckily it's not too bad, but there are a few things you need to do in order to get full credit on this one. So the first thing that we know is that by the fundamental theorem of calculus, if you have something like this, you can rewrite that by taking the antiderivative. In part D, we actually can also take the antiderivative. There is one issue with that, and that's the fact that we have 2x, not just x. So because we have 2x, we actually are going to use u substitution. And this is a common type of thing for them to do on the AP test. They like to get problems that are somewhat similar to things that you've done, but they generally put in an extra step. So for this one, we're going to do u substitution. When I do u substitution, I end up getting, by the way, with u substitution, I always like to rewrite my constraints just with the first variable that I started with, just to be safe on that one. So I have the integral from x equals 0 to x equals 1 of g double prime of u du. And don't forget that the du is over 2, so I'm just going to put a 1/2 in front. Now that I actually have it in this format, I can simplify it out. I can take the antiderivative. The antiderivative of g double prime of u is g prime of u. That's going to be from x equals 0 to x equals 1. So now make sure that you substitute your u back in. I get 1/2 times g prime of 2x from x equals 0 to x equals 1. That's going to give me 1/2 g prime of 2 minus 1/2 g prime of 0. And you can use the table to evaluate your g prime. So I get I get 1/2 times -2 minus 1/2 times -5. That gives you -1 plus 5/2, which gives you 1.5 or 3/2. So in order to get full credit on this problem, the first thing is you need to use u substitution. The second thing is that you need to get a correct integral. And then the last thing is you need to get the answer.